Okay, next one. Now we're up to the bisque firing stage. And the only thing I could think of here relative to this was, you may have this bisque firing, but you may have heard the term biscuit firing. Has anybody heard of that? Yeah. Well, and what we do most of the time is actually biscuit firing. Biscuit firing means you fire, the first firing you do to a lower temperature than the second or the glazed firing. That's biscuit firing. Bisque firing, again, the classic definition is the first firing is at a higher temperature than the glazed firing.
What?
And we've gotten very casual and sort of sloppy about this, but technically that's what the difference is. Bisque firing, the first firing is at a higher temperature than the glazed firing. And this is done a lot in industry. If you think about it with dinner, you think about the way you get losses in pottery and the way things happen, is that in industry, they don't want to process a whole lot of plates and bowls and cups and things all the way through the glazed firing, only to find out that they have cracks. So they do the high firing first with no glazing. If the piece is intact and it's sound, then they'll go ahead and glaze it and fire it at a lower temperature, and their losses are practically zero. They don't want to have to put all the effort and the money and the expense into glazing a piece only to find out that it had a crack when it fires. So they do this. They high fire it first. The other thing that they can do, which is really clever with this, when they do the high firing with no glaze, have you ever some of these plates that have these incredibly thin rims that are hanging out into space? They can fire them on supports. So they can take a dish, it's called a setter plate or a setter form, put the dish in it and completely support it while they're high firing it. So if the clay would warp or droop a little bit, it's totally supported during the first firing. And so when it comes out of that, it's never going to warp again anymore. Now they can glaze fire at a lower temperature, and again, they cut their losses from warping and drooping and slumping and all that stuff. So it really makes a lot of sense. We've gotten really casual in our usage of the terms, though. Any questions on that? I just thought I'd bring this up because in case you'd heard the term biscuit. So there really is a difference. And what we're really doing most of the time is this, even though we call it that. Okay? Okay. So the next stage in the process refers to glazing. The first thing I think I just mentioned, again, you may have heard some of these before, but I wanted to at least cover my list. First one is just the term flux. And this goes back to the fact that a glaze really consists of three sort of categories of components. What are called fluxes, stabilizers, and glass formers. And so except for things like colorants and additives, the main body of a glaze, the glass, the main material that you're forming, all the ingredients, even if there are 15 of them, fall into these three categories. Okay? And basically, most glazes are made of, most of the glaze, of any glaze, is made of silica. Silica is a really, and in case you're interested in chemistry, the formula is this, and it's silicon dioxide. This is a really common material. Okay, we're going to get into this. I'm introducing this now. We'll talk a little bit more about it later. But it's a really common material, and it's available. It's in your backyard as a rock, and this is it. It's quartz. Quartz is one of the forms of silica. Okay. Now it may look something like this. This is a really pure form of quartz, where it's clear, but it's exactly the same chemically as this, which you just find in your backyard, and it's also exactly the same as this ordinary sand. Most of sand is just silica. Okay. So when we're making a glaze, what we're really doing is we're taking the silica and melting it. That's what we're doing. And then we add other things to it. We change the color and we're modifying it. But that's basically what a glaze is. We're melting this. The problem is silica doesn't melt at a temperature that we can reach with our kilns. It melts at over 3,000 degrees. So if we want to make glazes out of this stuff, and there aren't too many other choices, we need some way to make it melt at a reasonable temperature. That's what a flux does. When I add a flux to silica, together it lowers the melting point. Okay? So the flux, you can think of it as sort of a melter. Okay? We're going to touch on this a little bit more, but any questions on that? So that's what when you hear about, and there are fluxes in glazes, there are also fluxes in clay bodies. Because in order for a clay body to fire properly, you need a lot of what's going on in the clay. You need the same thing that's happening in the clay as what's happening in the glaze. And the clay bodies, except for earthenware, actually melt a little bit when you fire them. There's some partial melting going on, and that's due to these. Okay, so the flux is just a melter, and there are fluxes in glazes to help the glaze completely melt, or there are fluxes in clay bodies to help it partially melt. Not in earthenware so much, but in cone 6 materials, and especially in cone 10 and high fire, there are fluxes that help the material partially melt. Okay?
Oh, so then the flux is used to sort of categorize the glaze.
Well, that's one way to think about it. Yeah, because and the flux, not only, it has other effects also. Not only does it affect the melting, for instance, it also affects the color. So for instance, if everything else in a glaze is the same, and let's say I have copper in the glaze as my colorant, if I change the flux, I'm going to change the color I get from the copper. So it not only affects the melting, its main job is melting, but it has other effects that affect the other properties. So yeah, you can talk about, so they talk about like alkali glazes, they categorize them like that, which is referring to the kind of flux that's in the glaze. Yeah, that's right. Yeah. Do you have a question, Amy? Oh, okay. Okay, along with the flux is another term that's related, is frit. What's a frit? A frit is powdered glass, basically. But it's a powdered glass made to a very specific composition. And when industry is formulating glazes, they don't like to use naturally occurring minerals as little as possible because they vary in composition. You dig a hole in the ground and you dig a mineral out of the ground 1 year and you keep digging in that hole. A year later, there's no guarantee that what you're digging out of the ground has the same composition as what you got the year before. Well, industry doesn't like that. They can't stand that because they've got to constantly make adjustments. So instead of maybe using feldspar as a flux out of the ground, they might use a frit. And a frit is a factory manufactured glass to a very specific composition. And it could have the same composition as the feldspar, as the natural mineral, but it's controlled. That's the point. So if they buy a certain frit now, they can buy it 20 years from now and know that it will be exactly identical. Okay, and for instance, there's a frit that has the exact same composition, basically, or pretty close to Gerstly borate. Well, industry wouldn't use Gerstly borate because it's so variable. I mean, it's notoriously variable. But they might use the frit because they could always get the same composition. Okay? So, and they literally and they're available in hundreds of different compositions. You can get them with, a lot of ceramics companies still use lead in their glazes. There's nothing wrong with lead in a glaze if it's fired and handled properly. So you can get frits that have lead in them. You can get frits that don't have lead in them. You can get frits that melt at different temperatures. But when you put the frit in the glaze, it basically acts like a flux. So that's frit. Along with glazing, another term that I wanted to just mention briefly are ash glazes. Talking about different kinds of glazes. And the reason why I wanted to bring this up is what are called ash glazes. They're ash glazes originally because they literally contain ash, mostly usually wood ash. But you say, well, who cares? Well, the reason is because the composition that you get for a glaze that has ash in it develops certain very specific characteristics that you like. And one of the characteristics is, this is a really good example of Dennis's, this is an ash glaze. I'll pass this around in case you haven't seen it. That's an ash glaze on the rim of the cup. They typically develop these strings or rivulets when they melt, and they tend to be very runny, and they tend to flow. But when they flow, they don't flow in sheets. They break up into these little streams or rivulets, and so this is a desired effect, and this is unique to the composition that you get by putting ash in the glaze. Now you can also get fake ash glazes. I can simulate the composition of ash just with a bunch of chemicals. So I can make a glaze that looks exactly like this, that no ash in it, and it's a fake ash glaze. Okay? But that's the reason why, that's why people, when talk about ash glazes, that's what they're after. It's not just that, if they're not after that, there's no reason to put ash in the glaze unless it's cheap and you want to use it. But that's the main motivation, is to get that special effect when they melt. And this is what the ash contributes to the glaze.
So, but you could say ashes are really variable too.
Oh, absolutely.
Mango, blah blah blah. So,
absolutely.
but there is a consistency in the result.
There is pretty much, yeah, the different ashes will give you different colors, and there is some, but one of the main things is a lot of wood ash now contains a lot of calcium and potassium. And and it may vary, but there's still two of the major things that you get out of wood ash are calcium and potassium, and lesser amounts of sodium, magnesium, and a whole bunch of other stuff. But those are the two things in particular that contribute to these properties of the glaze.
Would those be woodcraft food safe?
Yeah, oh, they're absolutely, yeah. Yeah, because I could make that exact same composition with chemicals out of a bottle. I could take limestone and potash feldspar, and if I wanted, and if I could get that exact same composition, I could get the same effect. So it's absolutely food safe. Yeah, at least from the glass point, not the colorant, but from the glass point of view. Absolutely. Yeah. Yep. Yep.
So it's not really fake.
No, that's a real ash glaze.
Fake news is fake news, but fake ash glazes are really just constituted with the same materials.
Well, the fake ash glazes, they call them fake because you're not using ash. You're making synthetic ash.
So inauthentic.
Yeah, yeah.
But you can also fire that like lower temperatures. Like you would think of an ash glaze as like a wood fire 10 or something.
You can make a really nice cone 6 ash glaze. There are a whole lot of them out there. Oh yeah, yeah. It's just that what it is about the ash glaze is the glaze, when it melts, there's another term that I wasn't going to go into, but it's called the surface tension. It's how the glaze wants to pull into itself. When you make an ash glaze, it has high surface tension and low viscosity, 2 more terms, which means that it's very runny, but the glaze, even when it runs, the glaze wants to stick together and wants to pull, and that's why it pulls itself into these strings, because the minute the glaze melts, it's sort of attracted to itself, like mercury. It's attracted to itself, but it still is very runny. And if you hit this certain composition, you get that characteristic, a very runny, but a sort of a cohesive glaze. So rather than flowing in sheets, it immediately pulls itself into these little rivers. Okay? But yeah, no, you can get some really nice cone 6 glazes that give you the exact same effect. That is a cone 6 glaze. Yeah. 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 Okay, ash glazes.